Hey everyone, it's Daniel. Here's a type of question that the SAT and ACT both really like. A store takes 10% off the original price of a laptop. No one buys it, so the store takes off another 10%. The laptop now costs what percent of its original price? It's tempting to say 80%. Taking off 10% and then another 10% might mean taking off 20%, leaving you with 80%. But based on the title of this video, you've probably guessed that there's a little more to it than that. The answer is not 80. Let's use numbers to illustrate. Let's pretend that the laptop costs $100. Doesn't need to be realistic. 100 is a good number to pick for percentages. If you take off 10%, 10% of 100 is 10. That would get you from 100 down to 90. Now we're going to take off 10% again. But be careful. We're not taking off 10% of the original number, we're taking off 10% of the new number. 10% of 90 is 9. That would get us from 90 down to 81. The answer is 81%, not 80%. So this brings up an important distinction for SAT and ACT questions. Many of them are as transparent as they seem. For example, many science questions just want you to read a chart or a graph. Many math questions just want you to solve an equation or isolate a variable. But other questions have something a little trickier going on. So let's talk about some of the most common answer traps that appear on the SAT and the ACT. This will help you avoid some common pitfalls that appear on every test. If you find any part of this video helpful, please comment down below, hit the like button, share, and subscribe. And be sure to hit the notification bell so that you can be updated whenever I post a new video. I really appreciate your support. Thank you. Okay, let's get to some common traps that appear on both tests. That last question was a good example of what I often tell my students. Think about where you are in a section in order to judge the difficulty. On both the SAT and the ACT, the math questions will appear in order of difficulty. In other words, the questions get harder as you move through a section. This is not necessarily question by question, but it is the general trend throughout a section. That percentage question that we just saw would probably appear somewhere at the end of a math section. So I'm not saying don't trust yourself. If you're able to do a question quickly, great. Still, if the question appears at the end of a section, it might not be as easy as it first seems. Think about where you are in a section to judge the level of difficulty. So for example, with the question just before, you can't just combine percents. Taking off 10% and then another 10% doesn't mean that you've taken off 20%. The questions at the end of a section will probably have another layer to them. Here's another trap that the tests love. In a rectangle, the length is 3 inches less than the width. If the area of the rectangle is 70 square inches, what is the length? Press pause, give it a shot. Back in video 11, we talked about let statements. Check it out if you need a refresher. This question is a prime example of when you would build a let statement. The idea is that we want to use the same variable for different terms. So let's call the width W. But instead of calling the length L, let's call the length W minus 3. It's 3 inches less. That way, we're using the same variable for both. And then from there, the formula for area is width times length equals 70. Subbing in those expressions would give us W times W minus 3 equals 70. Distribute through to get W squared minus 3W equals 70. We now have a trinomial. Time to set equal to 0 and factor. So moving over the 70 would give us W squared minus 3W minus 70 equals 0. And now factoring would give us W minus 10 and W plus 7 equals 0. Setting each one to 0 and solving would give W equals 10 and W equals negative 7. So right away we can reject the negative 7. That's not possible for a geometry question. That means W equals 10. The width is 10. However, remember that the question was asking for the length. They tell us that the length is 3 inches less than the width. So if the width is 10, it means that the length is 7. The answer is 7. However, if this was a multiple choice question, 10 would absolutely be listed among the answer choices. And this brings up a very popular trap that you might see on either test. The question we just saw had a whole lot of math steps, so along the way you get very focused on factoring that trinomial and solving for W. And when you finish and solve that W is 10, you think you're done. and the test loves to do this. In other words, if a question requires 5 steps, the result that you get from step 4 will always be listed in the choices. And the test will do this in other ways as well. For example, if they ask for a non-shaded area, the answers will absolutely list a shaded area. If they ask for the probability of what didn't happen, they will definitely list the probability of what did happen. So make sure that you've solved for exactly what the question has asked for. Here's a good tip. Reread the final line of any question before you bubble your answer. This way you can double check that you solve for exactly what they want. If you do all of your math correctly, but then solve for the wrong variable or stop one step too soon, that number will definitely be listed in the answer choices. So be careful. The tests also like to ask about surveys and data collection. Here's another common trap that might come up. Brian asks a random sample of amusement park visitors how long they had to wait for the flight simulator ride. He found that the mean wait time was 80 minutes, with a margin of error of 12 minutes. What is the best conclusion that can be drawn from Brian's survey? First, let's define margin of error. Margin of error is, well, the margin of your error. It means how much you're off by. So, for example, if they measured something to be 73% with a margin of error of 2, it means from 73 you can go up 2 and down 2. So the range would be between 71 and 75. Margin of error means you could add and subtract that number. So now that you know that, press pause and take a shot at the question. It's very tempting to say that the answer is C. It is likely that all visitors waited between 68 and 92 minutes. But the answer is actually D. It is plausible that the mean wait time for all visitors was between 68 and 92 minutes. And this brings up a very annoying trap where they like to get you. Margin of error does not mean that the final answer must be in that range. It means it's plausible that the mean falls within that range. It's semantic and annoying, but that's what they want. I don't like it either. Here's another survey question that the test really likes. School District 174 contains 3 high schools. 50 high school juniors were selected at random from high school B in that district. Of the 50 students surveyed, 41 responded that standardized tests were completely useless. What is the largest population to which the results of this survey can be applied? Press pause, give it a think. Here's how the SAT wants you to think. If you take a random survey of certain people in a certain geographic region, then you are allowed to project those results to those types of people from that geographic region. So in the example above, you can't say that the results are true for any other students at that high school, nor can you say that it's true for any juniors from any other high school in the district. But if you take a random survey of just the juniors at a given high school, you can project those numbers to the rest of the juniors at that high school. So the answer is D, all juniors at high school B. Now, full disclosure, I don't think this is true in real life, but for purposes of an SAT question, that's what they want. You can take the results of a survey and project them to a larger group, but only to those types of people in that part of the population. Here's another common trap that might come up on a survey question. The table above represents how the 238 students in the junior class are going to spend summer break. If one of the students who is going to travel is chosen at random, what is the probability that the student chosen will be a girl? Press pause, give it a try. They are asking for the probability out of those who travel. That means they are not picking from all 238 people. We are only picking from the column of those who travel. So the total number is not 238. The total number would be 46 from just that column. So the probability of picking a girl from those who travel would be 21 out of 46. And this brings up a very common trap for the probability questions. They love to ask for probability from a chart, but they don't want it out of all of the data. They only want it out of a portion of the data. So be very careful what they want you to pull from. That determines the number that will go in the denominator. Let's look at one more survey question. 15 students were asked how many hours a week they spend using social media. The results are shown in the given table. What is the median number of hours that these students spend using social media? Press pause, give it a shot. It's very tempting to look at the numbers on the left, 1, 2, 3, 4, 5, and say that the median is 3, the number right in the middle. Median means the number in the middle after you've listed them in order. But that's not true in this case. Why? You have to account for the frequency. Those numbers on the right tell you how many times the numbers on the left appear. In other words, in the first row, that means 4 students answered with 1. In the second row, it means 4 students answered with 2, and so on. So your data is not 1, 2, 3, 4, 5. Your data is actually 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 4, 4, 4, and 5. If you were to list that data out, the median in the middle would actually be 2. So this brings up another very common trap. When they ask for median, make sure to account for the frequency. You can't just assume that it's the number in the middle. You have to list them the number of times that they appear. The last few questions all dealt with statistics, data, and surveys. The SAT and ACT love these questions. But now let's do one that involves some actual math. Solve for x. X minus 5 equals the square root of x plus 7. Press pause, give it a shot. The first thing to do here is to get rid of that radical. That means we have to square both sides. And be very careful on the left side. That doesn't become x squared minus 5 squared. You have to double distribute, or FOIL, depending how you were taught. So that would become on the left, x squared minus 10x plus 25, and then on the right, the radical would just disappear, x plus 7. Again, we have a trinomial. Time to set equal to 0 and factor. So moving everything over would give us x squared minus 11x plus 18 equals 0. And factoring would give x minus 2 times x minus 9 is 0, which means x is 2 and x is 9. So solving this equation means x is 2 and 9. However, this is a very special situation when you're actually not done. And the reason why is because of that very first thing that we did. The first step was to square both sides to get rid of a radical. When you square to get rid of a radical, it means you might get an answer that doesn't work. You have to plug them in to test them. Let's prove that. Take a minute and plug in 2 to the original expression, and then plug in 9. Press pause, watch what happens. Let's plug in the 2 first. 2 minus 5 equals the square root of 2 plus 7. On the left, that would give you negative 3, and on the right, the square root of 9. That means negative 3 equals 3. That's not a true statement. That means 2 was not a good answer. We can reject it. Now let's do the same thing for 9. Plugging in the 9 would give us 9 minus 5 equals the square root of 9 plus 7. 4 equals the square root of 16, so 4 equals 4. That works. That means that 9 is a good answer. So when we factored the original expression, we got 2 and 9, but only 9 was correct. However, if this was a multiple choice question, you can bet that the answer choices would absolutely list 2 as a possible answer as well. This is called an extraneous root. Simply put, when you factor a trinomial, usually both answers are perfectly fine. The exception is when you square a radical. If any step involves squaring a radical, it means that you have to test your answers. One of them might not work. Tricky, but now you know to look out for it. Let's do one more. And just to change things up, let's look at a common grammar trap. This upcoming sentence has a mistake. Think about why the underlined portion is wrong. Brought over from Polynesia hundreds of years ago, Australia now incorporates the bird as a mascot. Why is that bad? Well, let's look at that intro again. Brought over from Polynesia hundreds of years ago. What word in this sentence was brought over from Polynesia hundreds of years ago? The bird. According to the rules of grammar, when you have an intro and it's describing something, whatever it's describing has to be the very next word in the sentence. In other words, this sentence has to say, brought over from Polynesia hundreds of years ago, the bird is now the mascot of Australia, or something else, as long as the bird comes directly after the comma. The way it's written, it sounds like Australia was brought over from Polynesia, like they picked up Australia and brought it over from Polynesia. This is called a misplaced modifier. Again, whenever they give you an intro, whatever it's describing must be the next word. Let's try it on a question. Encouraged by the good weather, the trip was completed by the sailors in just 4 days. Press pause, give it a shot. So what noun was encouraged by the good weather? The sailors. That means that the sailors have to come next. We could eliminate A and B. Looking at C, the sailors completing the trip. That doesn't sound right. It's a fragment. The answer is D. The sailors completed the trip in just 4 days. Again, the subject must appear first. Okay, now we're warmed up. Let's make things a little harder. Think about if this sentence is correct as written. Raised on a plantation in Alabama, Helen Keller's handicap kept her isolated from the surrounding world. Press pause, give it a shot. Just like the first two, we have to think about what the introduction is describing. In other words, what noun was raised on a plantation in Alabama? Helen Keller. So the sentence appears to be right, but careful, it says Helen Keller's handicap. That actually means that the handicap was raised on a plantation and not Helen Keller. This is a little tricky. Even though it gives her name first, it is not correct as written. A possessive noun is not the subject. So the sentence should say something like, raised on a plantation in Alabama, Helen Keller was isolated by her handicap. Let's try one more. Because he went against the church's beliefs, Galileo's theories were considered heretical, even dangerous. Again, what noun went against the church's beliefs? Galileo the person. But the way it's written, it sounds like it's talking about his theories. So we have to change it to make it not possessive. It needs to say something like, because he went against the church's beliefs, Galileo was considered dangerous because of his theories, or other variations as well, as long as it says Galileo without the apostrophe S. So, be careful when they give you a possessive noun after the intro. A possessive noun is not the subject. These are some of the most common answer traps that appear on the SAT and ACT. Granted, many questions will be as easy as they seem, but others will be a little trickier. So, just to recap, think about where you are in a section to judge the difficulty of the question. Remember, they'll get a little harder at the end. With combined percents, you can't just add or subtract the percents. Make sure to solve for exactly what the question asks. Margin of error gives a plausible range for the mean, but not a definite range. Surveys can only be projected to those types of people in that geographic location. Again, I don't think it's true, but the SAT thinks that it is. Careful if they want probability out of just a portion of the population. With median, make sure to account for the frequency. Check for extraneous roots after you've squared a radical, and possessive nouns are not the subject. These are some of the most popular traps that appear on the SAT and ACT. As you work on your practice sections, see how many you're able to spot. Even if you can't always find the right answer, these are very helpful tools to help you avoid trap answers. If you found this video helpful, please hit the like button, leave a comment, and share. And be sure to check out my next video where I'll talk about some other great test-taking tricks. Thanks for watching. And remember, plan your work, work your plan.